Hello everyone. Today we are going to discuss the grade 11 unit 8 heat changes associated with chemical reactions. In this lesson we have to discuss about 4 activities. Now let's discuss the first activity. For the first activity we need 2 beakers, a thermometer, some sodium hydroxide and some ammonium chloride. This is how we do it. We take the 2 beakers and we fill it with water. We add about half full of water to the 2 beakers. Then by using a thermometer, we will record the temperatures of these 2 systems. After that, to the first beaker we'll add some sodium hydroxide. To the second beaker we'll add some ammonium chloride. After this sodium hydroxide and water reacts, we'll check the temperature again. After this ammonium chloride and water reacts, we'll check the temperature again. Now we have recorded the temperature before adding sodium hydroxide and after adding sodium hydroxide. We notice that the temperature has increased here. That means if the temperature was about 30 degrees here the temperature has become about 40 degrees. The temperature has increased when we add sodium hydroxide to water. And here, after adding ammonium chloride to water, the temperature has decreased. That means if here the temperature was like 15 degrees Celsius, it has become like 10 degrees Celsius. Like that, the temperature has decreased when we add ammonium chloride to water. What is the reason for the increase in temperature when we add sodium hydroxide and the decrease in temperature when we add ammonium chloride? The reason is, in this system, the heat is lost. That means the energy of the reactants, the heat energy is lost in this first instance. Because the heat energy is lost, the temperature is increased. Here, the temperature is increased. Here the temperature is decreased because the heat is absorbed. The products have absorbed the heat. Because of that, the temperature has decreased here. Once again I'll explain. In this system, the temperature is increased. The reason for the increase in temperature is the loss of heat. Here the temperature has decreased. The reason for the decrease in temperature is because the system has absorbed the heat. Activity 2. We need a beaker, a magnesium strip, hydrochloric acid and a thermometer to do the activity 2. This is how we do it. We'll take the beaker and we'll add about 10 cubic centimeters of hydrochloric acid into the beaker. After adding this hydrochloric acid to the beaker, we'll check the temperature and record it. After that, we'll take a magnesium strip about 2 centimeters in length and we'll add it into this hydrochloric acid. Then this magnesium and hydrochloric acid will react together. After they react, we'll record the temperature again. Now in this instance, the temperature has increased. That means after adding the magnesium strip to the dilute hydrochloric acid, the temperature has increased. As I told you before, the temperature has increased means the heat is lost. The temperature has increased means the heat is lost. That means the energy of the reactants, that means here the reactants are magnesium and dilute hydrochloric acid. The energy of the magnesium and the hydrochloric acid is greater than the products. Here the products are when this magnesium and hydrochloric acid reacts together, magnesium chloride and hydrogen gas is produced. So the products are magnesium chloride and hydrogen gas. Here the magnesium strip and the hydrochloric acid has a higher energy than the magnesium chloride and the hydrogen gas. That means the energy of the reactants is greater than the energy of the products. When the energy of the reactants is greater than the energy of the product, we call it a exothermic reaction. This is the definition for exothermic reaction. The chemical reactions happening with the evolution of heat are called exothermic reaction. Evolution of heat is the heat is lost, the heat is given out. These kind of reactions are called exothermic reaction. When the heat is excited from the system, we call it a exothermic reaction. This is how we can represent a exothermic reaction. Reactants gives products plus heat. That means the heat is given out. When the reaction happens, the heat is given out. So the heat is excited. So this is a exothermic reaction. This is the example. Magnesium and hydrochloric acid are reacting, and it is producing the salt magnesium chloride, and it is giving out the gas hydrogen. Here the energy of this magnesium and hydrochloric acid is greater than the magnesium chloride and the hydrogen gas. What is the reason for the evolution of heat in an exothermic reaction? Now the heat is lost in an exothermic reaction. We are telling in exothermic reaction the heat is lost or the heat is given out. What is the reason for this? The reason is because the energy of the reactants is greater than the energy of the products. Because of this only the heat is given out. That means the heat energy in these reactants cannot be absorbed by these products. So it is lost. There is no use of it. It is lost. Because of that the heat is lost. Activity 3. For the activity 3 we need a beaker, some citric acid and some sodium carbonate. This is how we do the activity. First we will take the beaker and add some citric acid into it. About 10 cubic centimeters of citric acid. We'll add the citric acid and record the temperature. And separately we'll record the temperature of sodium bicarbonate also. After recording these initial temperatures, we will add these 10 cubic centimeters of sodium bicarbonate into the citric acid. What happens here? Here, after we add the sodium bicarbonate to the citric acid, the temperature decreases. The temperature decreases means the heat is absorbed. Temperature decreases means the heat is absorbed. Heat is absorbed because the energy of the products is greater than the energy of the reactants. Here the energy of the products, that means the products energy is greater than the reactants. Because of that only the heat is absorbed. Heat is absorbed means this is an endothermic reaction. The definition for endothermic reaction is the reaction taking place with the absorption of heat are known as endothermic reactions. When the heat is absorbed, we call it an endothermic reaction. This is how we represent an endothermic reaction. Reactants plus heat, that means the extra heat is absorbed here. Reactants plus heat gives the products. The heat is absorbed and the energy of the products is greater than the reactants. The reactants have less energy than the products. What is the reason for the absorption of heat during an endothermic reaction? Because energy in the products is greater than the energy in the reactants. As I told you before, the energy of the products is greater than the energy of the reactants here. Because of that, we call this a endothermic reaction because the heat has absorbed. Activity 4. For the activity 4, we need some sodium hydroxide, hydrochloric acid, two beakers, a thermometer, a polystyrene cup and a glass rod. This is how we do it. First we'll take the two beakers and we'll add sodium hydroxide solution into one beaker, and into the other beaker we add hydrochloric acid solution. And we will measure the temperatures of these two solutions separately. After that we will take this polystyrene cup and we will add the two solutions into the polystyrene cup. We will close this with a lid, and by using a glass rod we will mix the two sodium hydroxide solution and the hydrochloric acid solution. By using this thermometer we will measure the temperature of the system. Why do we use a polystyrene cup here? This polystyrene cup is an insulating cup. We use a polystyrene cup in order to prevent the escape of heat from the system into the environment and to prevent the heat from the environment coming into the system. By using this glass rod we have to constantly stir the mixture in order to have a uniform temperature throughout the mixture. So now here we have the initial temperatures of the sodium hydroxide solution and the hydrochloric acid solution, and after doing this activity we have the final temperature of the whole system. While doing this activity we have to do some assumptions. We'll see what those assumptions are. We assume that the density of the solution is equal to the density of water. Here, because we use dilute acids, we can take the density of water is equal to the density of the solution. And also we assume that the specific heat capacity of the solution is equal to the specific heat capacity of water. And also we assume that there is no heat loss. We can use this equation Q equal NC theta to solve the calculations or to solve the questions related to these heat changes. Here simple M is mass of the solution, C is specific heat capacity and theta is temperature change. Later I will discuss some questions with you. Let's meet again with a new video.